Hey everyone, have you ever wondered what you can do with Raspberry Pi Pico and push it to the limit? Well, in today's video I'm gonna show you how to turn Raspberry Pi Pico into a handy 24-channel logic analyzer. So, let's dive into the tutorial. To begin the installation, I've included a link to the repository in the description below. But before you click on the link, please consider subscribing and hitting the like button. Don't be the kind of person who just consume information and disappear, alright? And once you click on the repo link, don't forget to thank the contributors for their efforts. Now, let's get started. Download the source code by clicking on the green button. Once the zip file is downloaded, you will have 3 folders. We need to access the second folder, then go to the build subfolder. Inside, you will find the firmware file with .uf2 extension. Next, grab your microcontroller, and while holding down the boot select button, connect it to your computer via the USB cable. The Pico will act like a USB flash drive. Simply drag and drop the .uf2 file into drive, and it will automatically eject. Now, your Pico microcontroller is ready to capture some signals. The next step is to download and install PulseView software. Once the installation is complete, the fun part begins. Once you finish all the installations, open the PulseView software. Click on No Device button to set up your logic analyzer. Select the Raspberry Pi Pico from the list, and then check the serial port settings. Make sure to set a higher baud rate for increased speed. Next, click on Scan for Devices. When your device appears, simply click OK. Now the Pico is ready. I will start by debugging the simplest data signal. Here on my bench I have an IR receiver with its output data connected to GPIO2. My goal is to decode the packet data received from the remote control. Now we need to select the sample rate and the frequency bandwidth. Next, we hide all logic channels except for digital 2. Then hit Run. As you can see, when I press any button on the remote control, the data is captured in real time. Now that we've received the data, I will search for the IR NEC decoder. Double click on it and select your digital channel. In our case, it's a D2. As you can see, the received signal has been successfully decoded. Here I have a WS2812 LED strip that I'm going to decode as well. It uses a single wire to carry all the RGB information for each LED. Now I'm running the Arduino sketch that drives the strip to display a specific color. In this case, I've set it to the green color. When I capture the data from the Arduino output to the strip, it will show the decoded color, which is, and this is for the red. Let's move on to the I2C data. I'm going to test it using the OLED screen, which communicates via the I2C interface. I've connected the SDA and SCL lines to D2 and D3, and I will run Sketch to display some graphics at the address of 0x3c, and then hit Run. With each screen update, you will notice data signals with different waveform. Now I will search for the I2C decoder. Double click on it and set the data and clock lines to the appropriate channel. The data frames pops up, showing the correct start and stop condition and the address of 3x3c that we set earlier. The data has been successfully decoded. Next, let's dive into the SPI data. I will be using the same OLED screen, but this time with SPI interface. Like we did with I2C setup, we need to connect the SPI terminals to the Pico input. I will be probing 3 terminals, MOSI, serial clock and chip select. Let's capture the data. As you can see, a waveform is generated with each screen update. And when we zoom in, we can clearly see the data stream that the Arduino is sending to the screen. Each data packet represents the graphic content of the OLED screen. Additionally, we can properly observe the signals the Pico is capturing, from the data signal to the clock signal. Lastly, I will wrap things up with this ST7735 TFT screen. To be honest, this software has so many decoders you can explore. There's really a lot you can do with it. So, here's the received data packet that has been sent to the screen via SPI. Let's wrap up our explanation of turning the Raspberry Pi into a powerful logic analyzer. We've covered everything from decoded signals. As you've seen, this setup can easily help you visualize and debug various communication protocols. What's even more impressive is that the PulseView software supports up to 130 different protocols decoders, covering a wide range of fields, from analog digital, audio, display, automotive, debugging, embedded systems, sensors, and wireless and cryptography. So I hope this video has shown you just how versatile and capable the Raspberry Pi Pico can be when paired with the right tools. So if you find this helpful, please don't forget to like, subscribe and share with others who might be interested. Thanks for watching and I'll see you to the next video.